everyone, my name is Tiara Permatahati from Universitas Informatika and Business Indonesia. Today, I'm going to share my research titled A Data-Driven Approach to Comparative Evaluation of Regression Models for Accurate House Price Prediction. So, here's the background. In Bandung, the property market is constantly shifting. The price can change quickly because of population growth, infrastructure projects, and economic factors. For developers, agents, and even buyers, having accurate price prediction can really make a difference in decision making. But the challenge is traditional prediction models often use raw variables only, things like building area, land area, and location without creating new, more informative feature. In this research, I wanted to test how adding feature engineering could improve prediction accuracy using 4 different regression models. The main goals of this research were: first, to see the impact of feature engineering on model performance. Second, to measure the performance using metrics like MIA, MSA, RMSA, and especially R-square. Third, to compare accuracy before and after feature engineering. And finally, to identify which feature really matters the most. The contribution here is showing that by creating the right engineered feature, like price per square meter, we can get a big improvement in accuracy. Here's how the research was done. We collected 7,609 house listings from rumah123.com. Here's how the research was done. We collected 7,609 house listings from rumah123.com in March 2024. The first step was data pre-processing. The process was removing duplicates, filling or handling missing values, and standardizing formats. For categorical data like location, we use encoding so it could be processed by the models. Next is feature engineering. We created new variable, for example, first price per m square, which is price divided by land area. This is important because in urban area, land is the biggest cost driver. Second is building land ratio, which is building area divided by land area. This is useful to see how intensively the land is used. And last is total rooms, which combines bedroom and bathroom to represent functional space. Then we trained 4 models: linear regression, KNN, random forest, and XGBoost. We split the data for 80% for training and 20% for testing, and used cross-validation to make sure the results were stable. The evaluation metrics were MIA, MSE, RMSE, and R-square. Now, let's look at the result in the numbers. For linear regression, the baseline R-square was about 0.5, and after feature engineering, it improved to around 0.8 in cross-validation. That's a big jump. And for KKN, the story is different. The baseline was around 0.6, but after feature engineering, it's actually dropped about 0.5. And this is likely because KNN is very sensitive to how features are scaled and distributed. And from random forest, we see a huge improvement from 0.7 to about 0.9. And XGBoost is similar too, from like 0.7 to about 0.9. We can also see the error metrics like MIA and RMSE going down significantly for random forest and XGBoost after feature engineering, which means the predictions are much closer to actual prices. This bar chart makes the improvement easier to see because random forest jumps from around 0.7 to almost 0.9, and XGBoost from around 0.7 to almost 0.9. Linear also improved nicely, while KKN is the only one that goes down. So the visual takeaway here is feature engineering plus ensemble methods like random forest and XGBoost give the most reliable and significant boost in the prediction accuracy. So to wrap up, feature engineering makes a big difference in predicting house prices. Random forest and XGBoost were the clear winner with a R-square score of 0.9 and 0.9. The feature, price per m square, and building land ratio were the most impactful. Ensemble models generally outperform linear and KKN. Linear gets a nice boost after feature engineering, but KKN is less stable in this case. Why is this important? Because it means developers and buyers can make much more data-driven decisions instead of guessing. Plus, the same approach could be applied to other cities with similar housing markets, showing how powerful machine learning combined with feature engineering can be in real estate analytics. So, this is the end of my presentation. Thank you for listening, and I'd be happy to answer any question or discuss any part of the study in more details.